Welcome back to another episode of I Make Free Energy for you guys on YouTube. Quickly gonna introduce you guys to a few free energy claims, and I want you guys to tell me what's wrong within 5 seconds of video. Let's go take a look.
Also jetzt haben wir
Nicht. Also die Maschine läuft langsamer. Der 500 Watt Strahler geht zwar, also die Energie.
Zien we nog storm, we give 8 arms and get.
see the spaceship, see how fast it is. This is how fast the generator is. Now it's producing a very high voltage. It's producing a very high speed. It's not slow, as you can see now. You see the rate at which the generator runs.
5 seconds of video claiming free energy, a machine that where the output is actually greater than the input. So not only there are zero energy loss in the system, but it goes beyond any laws of physics and logic at this point. However, definitely like transmission, either one, shaft, belt or chain are not a good way to transmit energy. So within 5 seconds you see someone with a free energy generator and a pulley system with belt and chain and stuff, it's automatically a fail, big energy loss. That is a big lie. So even if you're not an engineer or technical person, but at least someone with some neurons left in your brain, you figure this out within 5 seconds of watching that video, probably less. However, shaft it's 2 or more gears in a constant mesh in an oil bath. Why you need so much oil? Because there is so much friction going on. Energy loss can go up to probably up to 10% in worst case scenario. So definitely not a good choice to transmit energy. Belt requires very little maintenance, actually no oil at all. Unfortunately, belt puts too much stress on the bearings. Bearings, it's already a big cause of energy loss. Imagine putting additional stress on it. Yes, that's what a belt unfortunately is. Requires not so much maintenance as I said. However, belt is good for low RPMs, high torque mechanism. You need to keep the belt as short as possible. The last is the chain, which is probably by far the most efficient between the rest of two. Requires virtually no maintenance, actually a little bit of maintenance. You have to grease it once in a while. Good thing of chain is it doesn't put so much stress on the bearings, so the chain can be a little bit loose. Another big advantage of the chain is that you can stretch it out and virtually can transmit energy on a long distance, which is a good chain. You see good chain system on very high RPMs motors. There still again we have to consider the energy loss in the bearings, in the motor that generates heat, and also the generator itself. So this is, if you think that 5 to 10% is a very small energy loss, it's actually a big energy loss in the overall system. This machine, they shows that output is actually greater than the input. How big such a lie is? Come on, you know. However, all these have something in common: energy loss, energy loss, energy loss. I want to always repeat that. However, in our next video, we're going to show a totally different system. There is actually no physical contact between the two pulleys, but rather we have a bunch of magnets. So magnetism is the main force that actually drives our pulleys. So 2 wheels with a bunch of magnets and magnetism without physical contact perhaps people might think there is no friction. There's actually quite a lot of friction going on. That's what we call a cogging. We need to remember that magnetism is not a force. It manifests as a force when two magnetic fields get together and interact with each other. However, let's go take a look at the next video and let's see what it shows.
Je vais vous montrer comment on fait de l'électricité avec des aimants, avec simplement des disques magnétiques. J'ai un disque magnétique ici qui tourne avec un moteur de 2200 watts. Ici, un autre disque qui fait tourner un alternateur toujours de 2200 watts. Encore un autre, 2200 watts. Encore un autre, 2200 et encore un autre, 2200. Autrement dit, avec un moteur de 2200 watts, je vais créer ici 8800 watts d'électricité. Donc nous avons pu constater qu'avec un moteur de 2 kW2, on fait tourner 8000 watts, c'est-à-dire 8 km.
Very cute little grandpa. For as cute as it can be, that person is still a liar. Liar, pants on fire. This guy claims free energy. Yeah, input 2 kilowatts, output 4, 5, 6 kilowatts. Yeah, for sure. As we said before, magnetism is not a force, but when it manifests as a force, force unfortunately generates heat and friction. Yes, any kind of force generates friction. Today we're going to replicate the experiment, and I show you guys that whenever you apply a load to a magnetic rotating mass, unfortunately we do have a form of friction and suddenly generate energy loss. Let's go take a look at my experiment. And voila, here we have two beautiful pulleys without any physical or electrical connection. That's why we call it torque cogging, or simply cogging. The disposition of magnets are about repelling and attracting, repelling, and so on. So to give pretty much the maximum torque we can expect. So as we can see, motor and generator are electrically identical. So the specification too are identical. So if now in this system there is no friction whatsoever, no energy loss, the energy input, it should be the energy output. So input and output should match and be equal, identical. Now this is if there is no energy loss in the system. And I tell you straight up, there is a big energy loss in this simple system here. First one comes for obviously bearings, 1 and 2 bearings. So we have 2 bearings for each motor generator, front and back. Second one, it's the bunch of noise coming from the Lenz's law effect inside the magnets and coil. And the third one, believe it or not, it is the cogging system. And as we will see in this video, they're not as efficient as you think. We also have to remember that energy loss comes also from many other factors, including also that these two big pulleys, they actually pushing quite a lot of air. This is not a perfect vacuum sealed system, so air is surrounding these pulleys, and you're actually, believe it or not, displacing a lot of air around it. So as we can see, we have about 3 to 4 millimeters gap in between, so there is no physical or electrical contact between them. Yeah, at the same time we can transfer quite a lot of torque, as you can see. We will see now. So now let's turn this thing on and see what happens. So now power up, voila. I would like to show that there is still no physical contact, but still quite a lot of torque. Now it's about 5 volts. I can't really power this motor more than 5 volts. You know, that's what the specifications are, but doesn't really matter. About 100 milliamps consumption just to power this guy up. 100 milliamps, quite a lot actually. Anyway, this is without load. Now, if this system is one-to-one efficient, we should expect about 5 volts out of the output. And that, of course, if there is no energy loss, but as we just described and said that energy loss is pretty much everywhere, then a small energy loss in the system, including the wires, can add up and eventually have a big energy loss at the output. So here I have a beautiful simple multimeter here, some alligator clips, and now we're going to test the output. Now, as we said, if this is a one-to-one efficient system, we should receive about 5 volts as an output. But we actually don't. We have a merely 2.4, maybe a peak of 2.5, so we have about 50% energy loss in the system here. And the 50% energy loss, it's the sum of everything just described previously. Bearings friction, both of the bearings. Cogging system, that it's not a good efficient. It's not an efficient way to transmitting energy. Again, bearings. Again, we have a little bit of resistance in our cables. And so on. So we lost about 50% of the energy without even load, without load. So this is an open circuit. 50% energy loss, and that's only if there is one generator. Imagine if you have to add multiple generators, how much the energy would drop. So now, for the sake of the experiments, we're actually going to connect, instead of our multimeter, we are going to connect a light bulb, 5 volts rated light bulb, very common one. So now, if we're going to actually attach this guy to our generator, we notice that with the load, we end up having a lot of energy loss. You will see now. There we go. We have about, I want you guys to pay attention of our amps. That's about 160 over an open circuit, which is 100. So we have 60 milliamps over 100 milliamps. That's about 50% energy drawing, energy loss. You're actually drawing 50 to 60 milliamps just by having a load here. And of course, it doesn't even turn on, even though it's rated for 5 volts, because we just said the output is only 2.5. So this Cogging system here, it's not quite efficient as you might think, even though it looks kind of cool, doesn't it? So now, imagine again having more than one generator in cascade. Can you imagine how much energy loss we have? The resulting output would be less than probably a volt over like 5 generators. So we really have a big energy drop here. And that's all for today. But thank you guys for watching. Please subscribe. I'll see you next video.